All right, hello everyone. Welcome to the July 23rd, 2021 meeting of SIG Auth. Let's kick it off. It looks like we have a demo to start with. So I will kick it over to you. I guess I have to stop sharing.
All right, so can you make me a co-host so I can share my screen?
Stop sharing and all right, done.
Thank you. All right, so the demo is not really much of a demo, but I will do my demo anyway. But so I have a kubeconfig that looks like this, which is I have a server with a CA bundle, and then I have a proxy set as my exec plugin and nothing else. There's no creds. And when I run this, so I'll describe what happens. So there's some debug logging. One, it's saying that the proxy told me this is the port it wants me to talk on. I saw a set of CAs from the TLS handshake for client search stuff. And then I get data back because the proxy did all the authentication and grabbed all the data from the server, sent it back to me, and then the proxy exits at some point after that. So that's literally the demo, because that's really all it is. But yeah, I just wanted to have a chance to sort of talk through some of the details, because I know we had a KEP written by I think Micah, and honestly can't remember the other person's name. Nick, yes, Nick. So Nick and Micah had written that up, and I kind of just wanted to play around with the POC to see what was possible, just because I wasn't clear on a lot of details. So I just wrote out some code for this to kind of get people's feedback. But basically the gist is an exec plugin can optionally return proxy configuration data. And if it does, it'll be allowed to run indefinitely. And then kubectl will send all of its traffic that way. The way I kind of wrote it out was I basically required MTLS between the local proxy and kubectl, because otherwise you just have a random port sitting around that anything on your box can talk to and get authenticated as you. I went with this approach over any named pipe or domain socket approach, because this works everywhere, because it's just a server running on your box. Let's see what else. Yeah, there's a bunch of open questions, but I kind of wanted to ask what folks thought. They had questions or concerns.
How are the MTLS certificates handled?
The MTLS, so the proxy just generates a CA bundle and a client cert and hands it back to kubectl. So then kubectl presents that every time it, or client go presents that every time it interacts with the proxy. And presumably the proxy is also verifying the client cert on the way in. But
are they regenerated for each connection?
Not well. They're every invocation of like
I guess.
Yeah, so every execution of the proxy that I wrote does that. There's no specific requirement that it has to be that way. The requirement is that there is MTLS, and you hope the proxy is enforcing verification of the client cert as a way of not letting arbitrary processes on your like your browser or whatever interact with this and just act as you against whatever cluster. In this particular case, the proxy is doing the TLS offloading. It's doing its own TLS handshake with the API server, authenticating as cluster admin and letting everything through. But this would allow TLS offload. This will allow request signing, custom headers, I don't know, other stuff that people want to do. Micah, do you have any opinions? Since
Yeah, I will definitely play around with it. Sorry, I missed the answer. Did you say that you were putting the for the MTLS talking to the proxy? Did you just drop the client cert in the kubeconfig?
So this is reusing all of the machinery for exec plugins, and one of the things that they can return is the client cert. It's just that now they can also return the proxy configuration. And the exec plugin effectively saying, if you send me a proxy configuration, you must also send me a client cert to talk to it.
Gotcha. Okay.
So yeah, in a sense, what I've done is I've said that the credential that you can return can also be a proxy in addition to the token / client cert. So the code to do this is not necessarily pretty, but it is a very relatively small amount of code because all the machinery already exists to do this because we've already written it.
It actually makes a lot of sense that the proxy is taking on the role of the Kubernetes master, so that rather than the Kubernetes master's client certificate and CA bundle, that the proxy or that the exec plugin is returning, it's returning the proxy's client certificate or the CA or the certificate used to talk with the proxy rather than the certificate used to talk with the master.
Yep. Go makes this kind of annoying, by the way. Like you can punch in client certs arbitrarily with a callback. You cannot do that with root CAs. So one of the gotchas in this is now whenever inside of client Go, when you do the TLS config loading, that is the point right now where the client Go plugin gets invoked. Whereas in the past, it was only invoked when you tried to make a request effectively. If we did not want that behavior, literally our only sane choice is to set insecure TLS skip verify true and then literally verify the connection ourselves. And in that verification, duplicate the standard lib and use a different CA bundle. And I decided that was atrocious and I didn't want to do that.
Agreed.
Yeah, so I can walk through some questions. So the lifetime of the proxy right now. So the way, I'm on Mac OS Fox. So I spent a lot of time Googling this, but there is effectively no sane way across all 3 OSs to say, hey, I spawned a child process. I would like the child process to die when I die, regardless of how I die, if I get SIG killed or whatever. So Linux seems to have a relatively defined way. Good on Linux for that. Windows, I don't understand. There's something called a job and you can do something with it, but I couldn't tell if that would work on SIG kill or not. On Mac, like my machine, the proxy itself has just a Go routine that's trying to figure out
did we
We
lose?
lost Mo. I could fill in this part of his demo because he gave it to me yesterday. The proxy process starts up and is just sitting there in a loop, waiting for its parent PID to no longer exist. We will get Mo back to finish the demo though.
So I didn't quite follow the part about the root CA. Are we adding the proxy's root CA in addition? Oh, he's back. Okay.
Sorry. Yeah, I have learned that I should always lock my machine and unlock it before these meetings because I will inevitably lock my machine and then Zoom will stop working and then I'll have to sit there fumbling with my password. This literally happens to me every 4th meeting or something. So the CA bundle. So one of the nice features of the existing exec functionality is you can, on the invocation of the proxy, pass it the full details of the cluster that you're trying to talk to. So the proxy plugin knows exactly how to talk to the API server, including the correct CA bundle, proxy configuration, TLS hostname, all of that stuff. You, kubectl /client Go, now say, well, my host name is 127.0.0.1 and this port number, and the CA bundle to talk to that server is the thing that the proxy, the exec plugin just gave me, and that's what I'm going to talk to. So it's sort of just, instead of going that way, you kind of loop back to yourself for a second and then go back out to what you wanted to. I think there was like one other, someone.
So the question, so I think the question was in your output there,
yes.
in the log, it says acceptable CAs 184.
Uh-huh.
That really only needs to be one, right?
Yes. I was lazy when I was doing this. I was like, all right, I just need to make my server return some CAs or whatever. So I just returned my system root. But the idea is the client Go code could try to prevent invalid proxy implementations by both requiring that a client cert is returned and also requiring that its certificate callback is invoked, meaning something did try to make it do client cert auth. It cannot obviously enforce that the server cares on the other end, because that's the server's responsibility, but it can enforce that in the TLS handshake that it requested client certs. So that's all that log is doing, that, hey, like I was called and this is the CAs that the server said that it would accept for client cert authentication. But yes, that would be one in any sane configuration that I could imagine. And what Moira was saying in regards to the Mac thing, yeah, on Mac, apparently if you're a child process and your parent disappears, your parent implicitly becomes one, the init process, and you can detect that by just looping. So that's what I have it doing right now, because I couldn't come up with any way for client Go to guarantee that it would be killed. Also, originally I didn't realize that this was happening, so I had like hundreds of these little processes just sitting on my box, and like, I was like, oh, like, I think I'm gonna run out of ports pretty soon over here. So that was one bit. That one's pretty not great. Named, I looked some into named pipes. They seem to be well supported via the syscall standard library stuff for Linux and Mac. And Windows provides its own library, like from Microsoft for Go, that you can use. So that could theoretically be an alternative. I don't know then if we would do MTLS, like would we just purely rely on the file system permissions on those things? Maybe, I don't know. It still seems a little weird not to have any further protection, but I could kind of understand.
So named pipes was the proposal for Windows, but it was unnamed Unix sockets for Mac and Linux.
Yeah, so yeah, we could. I was trying to like be like, all right, what can I like vaguely do that looks at least the same across the OSs? I was like, well, named pipes is a thing, and because I think Windows actually has a Unix domain socket now. I just don't know if it actually works in this reasonably similar way. And I think it's only supported on Windows 10, which I guess might be fine. I don't know. I still have a Windows 7 machine over there for playing video games, so I don't know. Right now, I'm returning a port. Theoretically, you could imagine a proxy that wasn't even local on your box. I don't know if we want to support that, but if we wanted to support that, then it can't be just a port number. You need the host name. Oh, the big one, number 4. I don't think kubectl has any concept of like a feature flag. And the code is kind of invasive to do this kind of stuff. So I don't necessarily know how to protect users of client Go from what would be a very alpha feature.
Do we still have the alpha API of the exec auth?
Sure, but I plan on deleting it.
I guess. So does it matter? I guess you could just not use it.
Well, the concern I have there is that it would be part of an API that just went GA in 122. And if you didn't know, like it would be hard from the outside to observe that like this tiny section of an otherwise GA API is not GA. I feel like that requires some kind of opt-in somewhere. Like I don't think there needs to be an opt-in if the functionality was completely done and it itself was GA, but until then probably needs some kind of like I want this feature or something. Number 5, I don't really know what to do if the proxy just randomly dies. Like, do you just spawn another proxy? Moira had asked, like, could we? My original thought had been, well, we would run the exec plugin and it would spawn a proxy, and that would be long-lived, and then the original process, the exec process, would exit. But I think Micah and Nick didn't like that one because then the lifetime got even more harder to manage because you had like multiple hops and stuff. So I wrote the code to make it so that we would hang around and wait for the plugin and stream its output and decode and everything, but let it keep running. That code is not pretty, but it does work. But it still doesn't answer the question to me what to do if the proxy dies. And it would be much harder to even answer that question if the proxy is supposed to spawn a child process. I don't know. Let's see. Who asked about the overhead?
These are mine. I think I asked you some of these questions yesterday, but we didn't write them down.
Yes.
My only concern with having sort of this extra hop of local TLS is if you wanted to use this for kubectl, that would probably be fine. But if you're using this for like kubelet auth, you might care about the overhead of an extra local host round trip with TLS enabled. It wouldn't be like huge, but maybe something that would need to measure.
Or would client go just keep an open connection?
Yeah, there would be, yeah, I would expect that connections are still long-lived the same way they are between like client Go and kube API server.
Yeah, I think if you have a long-running process like the kubelet and it was using this, I don't think it matters at all because I think you amortize the cost of all of that over many, many requests. Maybe if you were running on like a box that was using kubectl and just continuously invoking this, maybe you were then being kind of wasteful because unless the proxy itself was caching its CA and client cert in an attempt to like sort of make it so that I don't even know if that would work. I don't know if the OS would let you reuse those connections. I suspect not. Mike, I did see some stuff about file locks, but it wasn't clear to me exactly how those would be implemented. But if you, yeah, I totally take a cross-platform way, especially if it can be something inside of client Go and not the responsibility of the proxy author.
I would say I think the proxy author always has to be semi-responsible for exiting if client Go has already exited and there's no automatic way to, forward signals for like SIG kills or something. But it could be kind of like a more standard or a easier, I guess making the signal cross-platform easier is the best solution that we can come up with.
Yeah, what are your thoughts?
Shutdown hooks in client Go?
Not for SIG kills.
Yeah, that was the thing. I didn't want something that almost always worked. I wanted something that either always worked or we just defined the contract for what you need to do either as the proxy author and what client Go will always do that makes sense for it to do. Because
oh, sorry.
Go ahead.
Maybe would it be workable to require proxy authors to say like, okay, set up your proxy as a normal system daemon on whatever platform you're running on, and then your exec auth plugin talks to that, retrieves the credentials, hands them off to client Go, and then immediately exits. Then client Go doesn't have to worry about managing a long-lived process. You kind of shunt that onto the proxy author.
That's a lot of complexity for multi-user systems, I think, if it can be
Yeah.
avoided.
Yeah, the thing I don't like, it's unclear to me how client Go would distinguish between a process that spawned the proxy, like an exec plugin that spawned the proxy and it goes away, versus a proxy that was spawned as one process and then died because of a bug. Like I don't know.
No, I'm saying you would always assume that exec auth plugin is just runs for like 1 second and then dies after returning the credentials.
Yeah, so that was my
like Mike
original
says,
thought.
then you
I
have
just
to
got pushed
worry
back
about
from
multi-user.
Micah and Nick, and I was like, all right, fine, I'll go make the other way work. Just I don't know what is actually easier to manage for users. Like I can see both approaches have some pain points, I think, either way. And I'm happy to do either one. I just did the one that was harder to implement because I can always just delete the code.
So not listening anymore on the proxy URL you return is a pretty good indicator, right? What are you using to decide?
Right now it's just a to-do. I was like, I don't know. I was like, I don't know what I should do right now.
And that would allow for both, unlike like waiting for if the child process exits or something.
Yeah.
That would allow both a system level proxy and a per exec proxy.
Yeah, I think originally what I was thinking is that if it's not listening anymore, the connection's closed, then client Go tries to re-exec whatever it was originally exec to start the proxy.
Yeah, I guess that makes sense. Kind of think, would we spawn some kind of Go routine that does like health checks or something, or would we? I guess we can come up with something, but all that seems reasonable. And so instead of relying on the process's lifetime, you rely on the network connectivity of the returned port. Moira, did you want to talk about the HTTP Connect reverse proxy bit?
Yeah, I wanted number 7 too. I think someone else kind of mentioned this already, but if you had a proxy that as part of doing the outbound connection to Kubernetes API needed to do some interactive prompt, like to unlock a smart card or whatever, you might want to pool that connection across many invocations of kubectl. Like I'm imagining something like a SSH agent kind of flow where my exec plugin spawns like an agent process or connects to an existing agent process and unlocks it. I think your code doesn't quite support that now, or it would, but you'd have to leave the plugin process running the whole time. You couldn't sort of just like return a pointer to return a handle to the long running agent process and then exit.
Yeah. So right now my code does not do checks to see if the proxy went away. It just kind of assumes it's going to stay around and bad things will happen if it's not around. But what you described does make sense, which is that we could support basically if you are going to spawn a proxy, we won't wait for you to exit, but if you do, that's fine, and we won't get upset about that. But we will get upset if the port you told us no longer seems to function as a server. That way, you could go the route of having a proxy, or having an exec plugin that itself is the proxy and is just sort of active for that one thing. Or you could have a plugin that spawns another process that's long-lived across arbitrary numbers of usages, and that exec plugin is then responsible for managing basically the CA and the client cert and making sure that, like, I don't know, randomly people can't steal it off the file system and or whatever.
Yeah, I mean, it would also be a place if you wanted to, let's say, even just prompt the user for if you're doing a username and password login, as an example, you can accept those credentials, load them into that agent process, and
Yeah.
not have to persist them anywhere.
I presume then the proxy author would have to come up with some mechanism to know that kubectl is being re-invoked. How is that invocation sort of authorized to reuse the session? Somehow, some way you would have to build that. So I guess it's fine. I don't mean, I can't stop you from building that anyway. So.
And we'll
And
have a
my-
bunch of dangling connections to Kube API servers now. But is that a common thing where for every single HTTP browser request, somebody has to touch a YubiKey? My presumption was the general flow was that you go to an auth server or an ODC server and re-authenticate every 24 hours to get a token, and that requires the touch.
Yeah, if you guys remember way back when forget what company they're from, some folks had wanted to do PKCS 11 in client Go, and we talked about it, kept for offloading some of that, but I didn't seem to go anywhere. One of the conversations I had with them was the fact that we needed to make it so that like you could establish this whole thing one time and then keep it around, because no one wants to sit there and touch their YubiKey every time they type in a kubectl command. It's just not practical. So
you also train people to touch their YubiKey all the time, which is not
exactly.
a good thing.
Yeah. Like I really like the GitHub flow where when you have to touch your YubiKey, you have to first go touch the button in the UI that says, I do intend to use my YubiKey now. Please prompt me. So like it's like very difficult to actually accidentally do that.
There are even more severe versions of that too, where you're not just touching the YubiKey, you're typing in your PIN on your smart card device. My last question there, I don't know if it's that consequential, but the way that you did the proxy here, it's kind of like a transparent reverse proxy. So kubectl client Go just thinks it's connecting to localhost, and it kind of doesn't actually, it's not really treating it as a proxy, it's just connecting it as an alternate endpoint. I think you considered also doing this, or you tried to do this also as like an explicit forward proxy. Did you?
Yeah, so I tried the proxy approach first, and both the implementation of the proxy was significantly more complicated because writing a man-in-the-middle proxy with HTTP Connect proxy is not fun at all. Like, like you're doing HTTP hijacking of the connection and other not so fun things. And then I also could not make like kubectl exec work. And maybe if I tried hard enough, I could have figured out what I was doing wrong. But I was like, I don't understand like if this is worth the pain and suffering.
I thought you said that at the top of your doc that kubectl exec did work.
In the approach that I eventually went with, which is effectively request rewriting, like it's just changing the round trip, it changes
the connect style version. Okay.
Yeah, the connect style version I couldn't make kubectl exec.
The only advantage I can think of is if you did want to have one proxy process that was being shared across many different contexts, many different clients connecting to it. That's hard to do unless you have like unless you're treating it as an explicit proxy that gets to know the destination endpoint each time. But even that is hard because you also have to remember all of the server info, like the CA bundle and all of that for each independent connection.
Yeah, I think we can still do that because like the code inside of the standard library for HTTP Connect stuff isn't that complicated for like the extra things it does for a proxy. Like I think it's like just a few extra tweaks to the request. We could just do the tweaks ourselves, so that way the proxy would see that, yeah, like you're trying to connect to server A and not server B. So then they could, if it wanted to do that, it could. We don't have to drop that information sort of on the way through.
And how does that work for HTTP2?
So on HTTP2, having written one of these proxies before, I've basically come to the conclusion that you need to build like two separate transports, one that's HTTP1 only and one that's HTTP2 only. And for all the exec and port forwarding things, you need to use one and upgrade. And then for everything else, you can just use 2 all the time, and it's just fine.
Specifically for the HTTP Connect proxies, does that
Oh,
is that supported on HTTP2?
I have no idea. I that might have been why it was blowing up for exec. I guess no, because exec doesn't use HTTP2. It uses 1 plus upgrade. I don't know. I don't know what Connect does for.
I think I know why it happened, but I'd have to page that in. It has never worked, I think.
Okay.
So
that tells me we should not use Connect proxies, because I would like all of kubectl to work and not some arbitrary subsection.
I think it's awaiting bug fixes, but it has never worked in the past, which is why I was surprised that it looked like it worked this time, but
yeah.
Maybe not.
No, I just went around it.
I guess there's also a question of how this feature interacts if you set a system level proxy or set the environment variables to set a proxy for kubectl. Like, do you want?
So in that case, it is up to the proxy author, but we forward the proxy information to the plugin. So we tell it an explicit proxy URL if that was set in our kubeconfig, because that's part of the cluster info, and we forward environment variables so it can also then decide to honor them. But yeah, so if the proxy author is written a nice proxy, then it should probably honor the whatever other proxy you have configured on your system as well. And as sort of as part of all this, my thought was that we would have an example implementation that did TLS offload, in the sense of you just provided it a key pair and it just used that. It's like hand wavy offloading, but to sort of build it in a way that could very easily be reused to build like a real one, like the one Micah wanted to build, just because it would be not, like, there's really actually not that much code in the proxy process other than like, here's my business logic and here's the stuff that's all the same across all of these. So like the idea would be like, here's the same stuff. You can add your business logic now and you're done. So I think we spent enough time on this. I just wanted to leave one final question, which is this a good idea? Like, should we do this?
I think it's a good idea. I think we should continue with the KEP and see if we can get it merged. But I'm glad that you were able to verify that this is reasonable. I'm interested to see the code. What's the diff look like?
It's not that great, but
is it not that bad?
It's gotten better after I've like gone back and forth on various things, but yeah, it's not that bad, but it's not as straightforward as maybe one might want it to be.
Awesome. Yep. Thanks for proving it out. Let's try to get an alpha KEP designed. And
yeah, Mo, I propose that you I bring you. Why don't you share the code with me and we can work on the existing KEP that I have this week and have something by next meeting.
Cool. Yeah, we can work on that. Thanks, Nick.
Awesome. And yeah, let's carry on because we're about halfway done. Client Go credential plugins, remove alpha 123, deprecate beta 123, remove beta 126. What is this, Mo?
Andrew Kiesler just finished the GA work for Client Go credential plugins, right? So they are officially GA in 122. Jordan and I reviewed all those things. They're all in. So I wanted to ask thoughts on sort of moving the ecosystem forward in regards to sort of slowly getting rid of the beta APIs. And I don't think we need to be slow on alpha, but just in general, I wanted to ask people's opinion, right? We have a V1 API now, but it is client facing and not server side. So just sort of what were folks' thoughts about giving people enough time to migrate away, but at the same time not leaving beta around forever.
So this is specifically for the exec credential plugin
Yes.
APIs.
Mhm.
I think this is reasonable. What is like, so when and why do we remove alpha APIs?
So like in this case, alpha has some sort of vague functionality that we never really supported forward. So it's kind of got some weirdness to it. I'm not sure when we normally remove alpha. My feeling was that we could have removed alpha a long time ago, but we just kind of left it around because no one was trying to remove it. But I felt that having one release of the GA API was sufficient to say, please stop using alpha now. I will just remove it.
Yeah, I think I agree with removing alpha features. I guess that is a reasonable motivation. I'm looking at like the RBAC or another API group, and we have yet to remove the API groups there. I don't know.
Well, so there are a few things going on there. The 122 actually stops the ability to serve alpha, beta, RBAC stuff. So we still have the types there, so that if someone still has data in a TD for some bizarre reason, like the API server won't explode, but you can't serve them anymore in 122. For the closest analog I can think of to the client, to the exec credential stuff is the webhook authentication, authorization, admission contracts between the API server and like out of tree implementations of those things. So even though we switched to V1 by default like a long time ago, if you set up an admission webhook talking admission review V1 beta 1, we will continue happily integrating with that backing endpoint in V1 beta 1 mode. Like what we expose as the API service from the Kube API server, we have a lot more visibility to and a lot more control over, and we can do a much better job of like making sure all of the in-tree implementations of controllers and manifests and examples and documentation update to V1 types. For integrations that people have written out of tree where Kube components are calling out to things, we've been a lot slower to just sort of drop a version.
Yeah, so I had basically that same internal thought. So I was like, to me, 3 was the minimum, but I suspected we would go slower. So then my question was, well, how much slower should we go?
Yeah, it would be helpful to sort of enumerate the benefits. So dropping the alpha, I think, is fine. I don't have any concerns with dropping the alpha on pretty much any timeline, actually. The beta version has been around a lot longer, and because we basically didn't progress the feature, is one of those like perma beta features effectively. And so
yeah, it was 11 releases.
Yeah. That's a good data point, Micah.
There's weight there. Just like
no,
yeah.
I get it.
So Micah, I did give you all of 122. I was going to delete it in 122, and I decided I would not do that.
I can make a PR to update that, or someone here can. Great issue if you want to make a PR to.
I think what would be helpful is to, just like we have the migration guide for the REST APIs that calls out like the differences. Let me drop a link. If someone can drop that into the meeting notes, that'd be useful. Just like we have that page that says like between V1 beta 1 and V1, like here's the differences. Basically, you have to specify the version you want. I'm just making this up off the top of my head. I don't know what they actually are. You have to specify whether you want interactive mode or not. That might have been about it.
Quick question. Do we tell things that we execute what version is executing them? Like kubectl 1.
Kube control version?
Yeah.
No.
Like even by environment variable or something, just so like we can know like here's like AWS CLI case, like what do we respond with, what format?
Yeah, if you ask for the cluster info, it's version to the version you asked, so you could
but that doesn't tell you the version of the client go live.
Yeah, it does not tell you if the client, for example, supports V1. This is why I wasn't sure what the timeline should be, because you as the provider of the kube config that will have a hard-coded version in it need to make the decision for what hard-coded version should be in there. Even if your plugin can speak all 3 versions, you still have to pick, which is not great.
Yeah, so enumerating what the delta is and what the costs of leaving the V1 beta 1 communication version in place, and if there are any things in the V1 beta 1 version we think are really dangerous or harmful or awful. So things that come to mind for the REST APIs were like really terrible defaults for some of the workload V1 beta 1 types, where it would be like, yes, please retain old replica sets indefinitely for all deployments. And it'd be like, okay, so I'm filling out CD. Like, why is this a good default? I'm shooting myself in the foot. Or for custom resources definitions, like by default, preserve unknown data and just like allow anything to be persisted in unstructured JSON. Like there were some really bad defaults. And so same thing for admission webhooks, right? Like timeouts were 30 seconds by default and fail open by default. Like it was just really terrible default behavior. And so the V1 beta 1 versions of those things represented foot guns that people were hitting regularly. So it wasn't just like a matter of cleanliness. It was a matter of like people using these beta versions are sort of in danger of hitting these bad behaviors. And so if there are similar things for this, that would be helpful to know. If there aren't, then I would probably try to get a sense from the ecosystem, like what SKUs are people supporting, like kube control versions, and do a straw poll of how people are configuring the exec plugin, and then go from there. Especially if the cost is low to us and there aren't really just horrible downsides to using the V1 beta 1 version, I would use that to inform like how many releases we leave the beta version in.
Yeah, I think it would be great if we didn't force a bunch of plugin authors to handle multiple versions for a period of time, especially if it's not causing too much friction for core maintainers.
If there are foot guns or there is high cost to keeping the beta version around, that would be good to call out as well. And we'll try to consider that and balance that.
Cool. Let's keep it rolling. And
can I ask one more quick question? Sorry about
sure.
that. When did we introduce V1?
22.
In about a week.
22. Okay.
Yeah.
Okay. If I'm just thinking like off the top of my head, if it's like, if we say, okay, we'll get rid of alpha, say I'm picking something, 2 years, that gives folks
Alpha
like enough time.
beta.
Oh, I guess beta.
Yeah,
I mean-
the current most stable version that has been around for like 11 releases
Right.
is beta. Yeah.
Yeah. Just giving people long enough time to not have to, like you're saying.
So
support
as
multiple-
as a straw person, how about instead of, so alpha goes away next release, we deprecate beta in 123. That doesn't necessarily mean anything yet. And we remove it in 129, as in 6 releases from when it was deprecated, which is 2 years. Meaning at 1.5 years in, you probably should start using V1 and you're probably fine because no one cares. Like no one should be hopefully using a cluster that is that much, or a kubectl that is that much older. Right? Like you get a very long buffer to sort of make that transition.
I think AWS CLI should upgrade to V1 Beta 1 ASAP.
Definitely.
And I think 2 years sounds reasonable, Mo. Yeah, that's a very long time.
What I
But
don't
I have
want
no
to
idea
happen is
what
never,
keep control.
yeah, I was saying what I don't want to happen is that it just stays around forever and we never actually
Yeah,
move forward.
I
'Cause
agree.
the point of version APIs is you're supposed to actually go up the version, not just, or at least up to the stable version, not just sit on it forever.
That's true. That said, the like beta version that's existed for 3 years, like we have a burden as well to provide a stable API in a timely way, and when we don't do that, it's sort of on us to recognize that people have built like production-ish things on our beta API, and so
No,
giving
like
them-
I own an exec plugin myself that uses the beta API. I'm not like not shooting my own self in the foot. I'm like, I'm thinking to myself how much suffering I'm causing myself by saying these words, but
yeah, I mean, enumerating the cost to maintain it and the deltas and risks of the beta version, and trying to figure out like what people who are using the beta version of the exec plugin, what kind of skews they're seeing. My guess is like a time frame like 2 years or 6 releases would be sufficient to say like the oldest kube controller you're using might be 3 releases old, and you might have a skew 1 or 2 versions on either side of that. If you're doing generic config construction and you don't know exactly what version of kube controller you have to support. So I like back of the envelope, that seems like it would probably be reasonable, but be good to write down our reasoning.
Awesome. I am going to try to keep it moving. So let's do this follow-up for Secret Store sub-project discussion. Who put this on the agenda?
Yeah, I added this in the last one, and then basically we discussed on why we require this. So this is actually the issue where users were requesting for the feature, and then like I had a small Google Doc for the proposal, like just the thing that the sub project wants to do. So the idea is we want to have a separate controller that does sync as Kubernetes secret as a separate feature because it's widely requested. Today, it's tied to the CSI driver mount logic, so which means you need to create a pod with the volume mount. And once you do that, if you also have the optional sync secret feature enabled, we will sync the mounted content as Kubernetes secret. And then there's been an ask where users don't want to do the mount, but they just want to sync as Kubernetes secret. So the idea is the CSI driver continues to do what it does, which is the mount. So users who want to do that can continue doing that. We want to split out the sync controller logic and then move that as a separate repo, or like, I mean, we still haven't worked out the details, but something that we can do where users can opt between the CSI driver or the sync controller. So they get like 2 different features and then they can choose which one they want to do with. So I put this on the agenda, I think, few weeks back, and then we talked about it initially. So I also sent a note to the SIG Auth mailing group. It received few reviews on the doc, but I'm just looking for more feedback. And if this is something that the community thinks we should do, then I can work on creating a detailed proposal with implementation plan on how we plan to do it.
I wish Rita was here. I think she's out of office today. I don't know. So this would be a separate subproject of, would be a proposal for a new subproject of SIG Auth.
Right. I mean, like right now it's all within one, but we could split it into another subproject and then basically just have users choose between the two. The good part is we have these custom resources and also like a way. So we use gRPC for driver to provider communication. So we would still use all those basics even for the other subproject. So in terms of configuration, users would still configure it the same way that they do it today, but it's just that each project has the feature isolated. So this one only provides the volume mount, and then the sync only provides Kubernetes secret.
Okay, so Kubernetes secret syncing is already something supported by Secret Store.
Yeah, we added that as an optional feature because a lot of users for the driver have been for Ingress controllers. So they need the Ingress certificates to be synced as Kubernetes secret. So.
I think I was the only one out of the leads that was here last time. I think my biggest concern was it doesn't make sense for something called the secret CSI driver to not actually be a CSI driver. Because it doesn't really make it, like, yes, the secrets API is nice and uniform and easy to consume and well supported in the ecosystem because it's what's there and it's always been there. It does significantly weaken some of the protections you get by not exposing those secrets into the Kubernetes control plane, right? So even if the foundation of these two very related projects was basically the same code, I would personally still want them to be separate things because the security properties of those two things are actually very different. Even if the code that implements them is not very different.
Right. Yeah, and I think like in terms of how we want to approach it, the CSI driver would still say CSI, but again, it only does the volume mount. So it uses the CSI spec to do the volume mount and everything. And we would extract the sync controller from it and then maybe just have that as a different project. And then in the future, once the adoption increases for the other sync controller, like users are actually adopting it, then we can decide to deprecate that in the CSI driver and just recommend users to go use that for syncing if that's all they really want.
And the driver code basically is the code that somebody would write outside of this repo, secret CSI driver, to like implement the integration. Is that portable across the two?
It is.
Okay.
Yeah, like the way we have it is like the driver or like the client makes a gRPC call and says, give me all these objects from the external secret store, and the provider returns everything back to the client. So like the logic for either writing it to the mount or syncing as Kubernetes secret, it's all still at the client level. So providers, if they have the plugin today, they can use the same plugin for the other sub-project as well. It's just that instead of a daemon set, they would have a controller that's running on the node. That's it. A single controller.
Right. Previously I thought the API also included like a pod namespace and name information on that mount call to the integration plugin. Is that true? So like plugins that depended on that would also not work for this because you wouldn't know when you create a secret?
Yeah, the pod name and namespace, at least like for the Azure plugin, we used mostly for the auth scenarios, like so that metadata can be used for getting a token. but like there would be some limitations in terms of the permissions that need to be given. So today with CSI, the benefit is you can basically provide the required permissions to your individual pod rather than giving it to the daemon set, like the CSI driver daemon set. But in case of having a separate controller to just sync as Kubernetes secret, I think like that is where that limitation comes in. Like you probably need to assign those permissions to the controller. But if you're probably using like for GCP workload identity or like identity specific to a particular pod, you could still go at a granular level and grant permissions only on that pod. And then the provider today already fetches the token by the token review API.
Right. I'm interested to understand how this works for a like how you decide what namespace can ingress secret can be synced into, but I guess that's already implemented somehow, so I should follow up. I think I probably feel the same way as Mo, that it's worth separating from the CSI driver stuff. How did we do this last time? Was there a KEP or just a proposal on the mailing list? Do you remember, Mo?
I thought we like made an issue to some repo to request, or some GitHub repo to request the stuff, and then had to be signed off by the leads, and then someone else from somewhere else signed off on it. We should probably be able to dig that up on GitHub. I did want to ask, because Mike, you brought up a good point, which is, did you guys build some kind of authorization mechanism for who can request what secret? Or is it just if you ask for a secret, it will be given to you regardless of any like policy?
Yeah, today it's tied to the pod, right? So the user creates a custom resource called secret provider class. So that's where they tell which all secrets to get, which provider to use, and then like the auth mechanism. And then the driver at that point reads it and then sends it to the provider, like the whole thing. And then the provider uses different auth mechanisms at the backend. So like for GCP plugin, today we use workload identity, which is assigned to that particular pod. So it sees that it can connect to the secret manager and then get it. And similarly for Azure, we have pod identity. So the permissions are given to the pod, and then we use that identity to basically talk to the secret store.
Okay, so all that makes sense. How does that translate into secret syncing? Is that just because it's happening in sort of in line there? So the authorization is effectively already linked, like it's already strongly authorized, so you don't have to do any other mechanism for the syncing?
Yeah, and the syncing happens in the same namespace as the pod. So like everything is just within that one namespace.
Okay.
Does the controller run in every namespace, or do you have one global controller?
Just one global controller runs as a daemon set because CSI needs it to run on every single node. So today it runs on every node.
Okay. So how, if you had, so say the CSI stuff was gone or whatever, and you just have the secret syncing bits as a distinct project, what would the authorization mechanism exactly be when I ask for just, like, I guess, where do I ask for some secret to be synced exactly? And then who authorizes my request and gives me the secret?
So for the calls to the external secret store, we would still rely on what we do today for auth. But I think like the RBAC scenarios on where we can sync the Kubernetes secret, like I think that's something that we need to write in a proposal. Like that's something that I can work on and show it to you in the next call.
Okay.
Yeah, that sounds good. So last time we did a review of code and API before we did a kind of once we decided that it would be good to be a SIG Auth subproject. Right. So we can get that started, and I guess we'll have some people review and comment on this doc before next meeting, and see if we can hash out some of the open questions offline. Sounds good. I do apologize, we are over time. There's one more item. I'm going to push it to the top of next meeting.
Go read the doc.
But if you want to make an announcement.
Yeah, we just want comments.
All right. That sounds good. Thank you, everybody. We'll see you all in 2 weeks.